presentation. Yeah, I think you had quite some introductory talks also on Open RUN in particular, so I don't need to tell you what it is, except that you know, things are changing, and things are becoming more software defined, more open, more programmable, and flexible. So today in an Open RUN network, you have RU, radio unit, distributed unit, and centralized unit, whereas the distributed unit and centralized unit can run on general purpose computers, like we, for example, using Open Interface. But the point I want to stress is that Open RUN is not the same as open source. So Open RUN defines the open interfaces that let you, you know, so that you're able to interoperate different equipment. So a CU from one vendor with a DU from another vendor. But it's not the same as open source. However, the combination of both Open RUN and open source is a very powerful tool to build sovereign networks. So, which is a goal both in the United States and also in Europe, to get to be able to master the technology behind these networks better, and to be able to build these things with the technology available in these countries. So Open Interface is, as you have seen, the most complete open source implementation of 3GPP technologies. So both 4G and 5G RAN, and core network, also evolved packet core for 4G and 5G core. Of course, there's other software there too, and I believe during this workshop you have also seen, for example, SRS LTE or SRS RAN, which is similar, but only focuses on the RAN component. There is other software, for example, ORAN itself has released open source software for the RAN, but it's difficult to use this software to actually build your own network. There's some of it is dedicated to specific hardware, and it's not straightforward to put these pieces together to build your own network. On the core network side, so both 4G and 5G, there's more competition, let's say. There's software from OMEC, from Magma. There's which Magma, which contains some of code from OpenAir. There's Free 5G and Open 5G-S. And what you also see here is the different licensing models of these different components. And I will tell you in a minute what we use at Open Interface. Before I do, let me just quickly acknowledge the Open Interface Software Alliance, which was founded by Eurocom a few years back to support the growing interest in Open Interface. And we're happy today to have all these different members in the Open Interface Alliance. And we're also very happy to have, you know, our so Power itself is a member of the Alliance, but now there's also OpenAir X Labs organized this workshop, who can be seen as a kind of a sister organization to the Open Interface Software Alliance. So the goals, so the original goals of the Alliance were to promote Open Interface and its open source licensing model, support the community of developers and users, and it's an endowment fund, so we accept donations, and these donations allow us to maintain an engineering team here on our side in France, to help people with the integration, to help run and maintain a continuous integration system, so to guarantee that allows to guarantee a certain quality in the code contributions. And more recently, we've also started to accept donations to actually drive the development forward. So initially, this was done by the different partners of the Alliance. Now the Alliance itself is doing some developments themselves. And the work is split into three project groups. There's the 5G RAN group, 5G core network group, and the recent addition is the Mosaic 5G group. And I'm going to say a bit more about each of these groups in the following. Coming back to the license, so Open Interface uses the so-called Open Interface public license. So this license is a compromise between classical open source licenses and the way that intellectual property is handled at the level of 3GPP. So it is derived from an Apache v2 license and has additional clauses for commercial use that basically allow people to contribute code even though it has been patented for use in 3GPP. So this was very important to us to basically bridge the gap between existing way that 3GPP works and the way that open source works. So almost all of our components in the RAN, in the core, and Mosaic 5G now follow this public license and OAI public license, which is also a key differentiator to our competitors. The only part that follows a different license is the MME, the release 16 MME, so which is used for 4G and 5G non-standalone. Because this was, as I mentioned already, was also integrated in the Magma Foundation project. And it was, for them, it was more convenient to have a 3-clause BSD license for that group. All right. So as you have just seen in the tutorial from Shweta, which was very impressive, by the way, you can build a whole cloud native deployment of a 5G network using Open Interface. And which can run on a classical server or on a Kubernetes cluster or similar, like OpenShift. Yeah. So, for example, you can imagine that you deploy your system on 3 different levels. You have the core, which runs somewhere in the core and the C plane of the radio, which runs somewhere in the cloud. Then you have your edge cloud, so which would then to which your remote radio units would be connected to. And potentially you have some control and management software or network functions that run either on one of those 2 infrastructures or in a different place. And so Open Interface provides all the components that you need. So for the core network, this would be the AMF, SMF, AUSF, UDN, UDR, NRF, and potentially also the control plane of the RAN, so the CUC component. On the edge, you would typically run all the radio components, or the CUU and all the DU components. And potentially, if you're looking for low latency applications, you can run the UPF, the user plane function, directly at the edge, to have low latency access to any servers or the internet. And then using the different projects from Mosaic 5G, for example, Flex CN, you can tightly control the elements of the core network, or with the Flex RIC you can control some elements of the radio network. Now this is I would say equivalent to what is called the Flex. Well, as the name says, is the Flex RIC is like the RIC that you have in an all-RAN network. On the next slide, I guess you have seen this already. Let me just be very quick here. These are the different options that are supported by Open Air Interface today. So we have 4G LTE, we have 5G non-standalone, and we have 5G standalone that works with the COTS UE and as well with the OAI UE. And there's also some intermediate mode that now is much less and less used. That was used in the beginning of the development, which we call the NOSN1 mode, which we used in the beginning to test the radio component of the 5G without any of the control plane or other or core network functionality. In terms of hardware platforms, we support the USRPs like they used in Colosseum, but we also support some commercial radio heads. For example, the Benetel the radio unit from Benetel, or from which already uses a partially compliant ORAN 722 split, or radio heads from AW2S, which use an EC split 8 based on EC. And here you can also see the UEs that we know that work in 5G NSA and 5G SA. In terms of functional splits, we have different possibilities in OAI. So there is okay, let's start within the DU. We've been using since the beginning the FAPI interface to interface the MAC with the PHY. Recently, we also integrated the 5G NFAPI, so you can actually separate the DU also in two components and have the interface over the network. Then between the DU and the remote unit, we have the ORAN 722 interface. So today that only works with Benetel equipment, but in the future we're currently extending the functionality to also work with different radio units, ORAN 722 compatible radio units. And northbound between DU and CU, we have the F1 interface, which is also interoperable with third party. All right. Yeah, let me just mention here that another ongoing project is the offload of the LDPC decoding to an accelerator card. So in such a virtualized environment, the main bottleneck that consumes the most processing time is the channel decoding. So it's more than 90% of the total RX processing actually. And so it is interesting to offload this to a dedicated hardware. And one such option is this Xilinx T1 card, and which contains two FPGAs, one RF SoC and one MP SoC. The LDPC decoding sits in the RF SoC and is actually hardened LDPC, so very efficient. And so we have integrated this in this with the card. So this offloading is already supporting and has supported and has been validated with the NR-soft model. Yeah, there was also some performance comparison shown here that shows that from an error rate point of view, the performance is comparable, while the execution time, of course, decreases. Skip that. So let me come to the roadmap of the radio, of the RUN, and let me show you. Yeah, I hope this is visible enough. So we recently made an effort to produce this nice slide for the roadmap. You can also find this on the web. So let me walk you through this. So right now, for the rest of the year, the focus is on stabilizing the different stabilizing the different procedures on the X2 interface and S1 in NSA to recover from link failures on the 4G or 5G links. Very heavy focus right now is also on improving the throughput. So we almost can achieve 100 megabits on the downlink already now with SISO in a 60 megahertz configuration. We still with a COTS UE, we still have some on some platforms we have some issues with packet losses, which appear only with the COTS UE and not with the OAI UE, which we're trying to iron out. On the uplink, the target is 30 megabits. We're not quite there yet, and one of the issues that we're having is with the performance of the radio of the USOP, which limits a bit the uplink performance. So that's why we have two targets here, basically target 1, target 2, and target 2 is planned. Target 2 is for the commercial radio units that have a better RF performance, and where we support also larger bandwidths than the USOP. So here we want to go to 200 megabits on the downlink and 60 megabits on the uplink. The second number here, 200 megabits, 400 megabits, that's for MIMO. So we already have basic support for downlink MIMO with the COTS UE. There's also link adaptation based on CQI and RI. And but we need to, before we actually get to the 200 megabits downlink, we need to iron out the errors that I mentioned before. You know, the packet losses, otherwise we won't get to the 200 megabits. Okay, but the functionality is there to get to the 200 megabits or the 400 megabits with the commercial radio heads. We just need to iron out the current packets. Other ongoing the plans for the roadmap on 2021 is the F1 AP integration that I mentioned. So it's ready, but it's not yet merged. The LDPC support again is ready but not merged. We're also working on supporting different sub-carrier spacings, 60 kilohertz and also 15 kilohertz. That's going. Yeah, as I said, the basic ORAN 72 support. Although I have to admit that today we don't have a commercial ORAN 72 radio head for testing. But this is ongoing, and we're hoping to get one by the beginning of next year so that we can do the interoperability testing. Now, looking a bit further to 2022, Q1, we want to improve the downlink MIMO to 4 layers. We have done all the groundwork and that we've laid all the groundwork, and so that should be doable within Q1. So with that, we should get a downlink throughput of 400 megabits with the UCPs and 800 megabits with the high-end RRUs. We're also going to work on the E1 AP. So the E1 AP is the E1 interface is the interface between the CU control plane and CU user plane. Yeah, that will allow you to do this deployment described in the beginning. We're planning to do some NFAP interoperability testing. Support for SRS, which is the uplink reference signal, downlink localization signals, and O-RAN interfaces E2 and O1. For Q2, our plan is to work on the FR2. So we have also already done some work on frequency range 2. The 120 kilohertz subcarrier spacing is supported in OAI. Random access procedure, including the beam selection support, is supported. But we never managed to complete the tests with the commercial equipment. So that's ongoing. And yeah, for Q2, we also then plan to actually really support commercial RRUs supporting the O-RAN 7.2 front. Looking a bit further, we want, of course, to support FR2 in SA as well. We need to work on the handover procedures for SA over the XN interface. We want to include some URLC features and also work on uplink MIMO. And one very interesting project as well that's driven by Fraunhofer in Germany is support for non-terrestrial networks, yeah, which is being specified right now in release 17. So which will allow communication over 5G with so using satellites, low Earth orbit, or even geostationary satellites to supply 5G links. So there's actually some good work already has been done, and some demos have been done already. And as soon as the release 17 is finished, we're planning to bring that back into the main development branch of OAI. How much time do I have left, Sheila?
So I think there's a lot of questions. So
okay, maybe let's take some questions.
Yeah,
yes.
Yeah, I think that's something interesting. So there's a lot of questions. So let me just go scroll through the chat so that I don't lose any question. So first was question, but it is asking like some clarification on the licensing model.
Yes.
Could you please elaborate a little bit more on why OAI chose a custom license instead of using one of the standard licenses for the open source software?
Yes. So the motivation for this is because Open Interface, and this is compared to other open source projects, Open Interface has always been open also in the sense of the community. So everyone who wants is allowed to contribute to Open Interface. Okay, so if you look in the code today, you see really a lot of different contributors from everywhere, and we wanted to create a license model that also allows you know, the key 3GPP players to contribute to our code. But under the classical license models, this was not possible because some of them, Nokia has several, I mean, essential patents in 3GPP, and with a classical license, as soon as you put something in the open source on which you also have a patent, you basically lose the rights to your patent. And so we wanted to create a license that is compatible with the 3GPP workings, and that's why we created our own license. Yeah. Other, for example, SRS RAN is also open source, But as far as I know, they don't allow anyone to contribute because they also reserve the right to relicense their code under different license. Yeah, they have a commercial entity which does that. Yeah, this is not possible with OpenAI.
All right, thank you. And I see there's some people from SRS in case they want to.
Okay, so if there's someone,
to
sorry
to clarify on this. There's another question on Slack that is asking, how does the UI project decide the 3GPP feature implementation roadmap? Do you go release after release, or implement certain popular features first? And I think related to this is like another question: does OAI implement LAA license assisted access?
Okay. So again, for the features, this is community driven. So whatever the community wants to implement will consolidate and bring that in. Of course, there's a focus on the core features. So first you need to have a basic 5G system up and running with that gives you a stable throughput and a stable connection. So of course the priority is on those features. But for example, the non-terrestrial network features that was driven by third party, even by the European Space Agency, who had an interest in that. Yeah, I mean, our role at it's the role of the alliance to collect all these inputs from the community and then come up with this harmonized roadmap that you see here. Regarding the LAA, actually that was even one of my personal projects. I really wanted to have that, but it turns out you can't do that with USRPs. USRPs, so for LLA, you need really low, you need to implement listen before talk, and you can't do that in a software using the architecture that we have today. You need support from the hardware to do listen before talk. So maybe some of the new radio heads can do that, and in that case we can bring that back. But with the USRPs, with the vanilla FPGA images that you have in the USRPs, that's not possible.
Yeah, and I think this resonates with something that we've been looking at that also. Then there's another question.
I see a follow-up question. Let me take this one on the license. So let me read that. I see that now too. So if you use OAI with features patented by Nokia, for example, do you have issues with the patent holder? That depends. If you use OAI only for non-commercial purposes, so research and others, you will not have any problems because that's stipulated like this in the license. However, if you decide to use OAI in a commercial deployment, or if you decide to build a product from OAI that you want to sell, you will have to adhere to the rules of 3GPP. So I'm not an expert there, but as far as I understand is that the 3GPP maintains a pool of licenses. And anyone who sells a 3GPP product, basically, you need to negotiate with 3GPP the share of the patents that you implement, and you need to contribute to the pool. So some of your part of the revenue will need to go into the pool and will be shared with the license holders. And so that was just the same as Nokia would have to do, or any other who provides products in. For 4G, 5G.
Yeah, and again on the license, we have a follow-up from Andre from SRS, but in the chat is saying that they allow contributions, but asking to sign a contribution license agreement.
Okay.
So thanks, Andre, for the clarification. All right, moving on to other questions more related to the functionalities. So one question is, are there any plans to offload part or all of the AOI file to the FPGAs on the SDR to improve the performance? And in this case, is there any plan to provide like bit files?
So I'm not aware. Okay, maybe let me rephrase the question. So there's I'm not aware of any plan to use the FPGA that's in the SDR in the for example the USRP to do any of that thing. However, this Xilinx T1 card that I presented can do more than just the LDPC decoding, and it is absolutely feasible to offload other parts of the PHY to that FPGA. We don't have very concrete plans on that, but yes, some people would like to have that. So you might see more on this in the future.
So yeah, I guess the fact that you don't have concrete plans will not allow you to comment on how you plan to release the FPGA acceleration part, right?
No, that's an excellent question. We will have to check with Xilinx. So I mean the code on the side of Open Interface will be released in the open source. The T1 card you can buy. The only piece that's missing is the bitstream and the drivers. We have not figured it out how we distribute those.
Yeah, I think that is a common question across different efforts, like how to distribute accelerated components. Then let me scroll a bit through the questions. So in terms of supporting URLC, what specific features at the run and core are you looking to add?
Okay. So in the first step, what we're going to do is add dynamic TDD configurations that allow you to basically decide on a slot by slot basis if you want to do uplink or downlink. That should already bring down our latency to a few milliseconds. So I have to add today the latency that we're getting with OpenAir 5G standalone is in the order of 9 milliseconds. But we want to bring it down to 1 or 2 milliseconds using the dynamic TDD and tweaking the and you know exploiting as much as we can the RRUS processes or some actually in even turning off the RRUS for some use cases. Going much going lower than that or so okay, and the next thing that we want to do is increase the subcarrier spacing to 60 kilohertz. That will reduce the slot duration to 250 microseconds, which will bring down which will halve the latency again. But I doubt we'll be able to go much further than that with at least with USRPs, because of the same issue that we have the latency between the host and the USRP. That limits the overall latency that we can get. So things like mini slots and we probably won't implement in OpenAir.
Got it. And I think let's take one last question, and then if you have a moment, maybe you can stick around to take a look at the questions on the chat because there's many
Okay.
interesting questions. And there's a question on like the plans for Q4 of 2022. So if you can elaborate a little bit more on what you plan to add for the NTN and the UL MIMO.
Okay. So so for non-terrestrial networks, we really want to have a release 17 compliant demo of a link, a 5G link over satellite. So that includes, so for example, the features that will be implemented are, or the main changes that are required to support non-terrestrial networks is basically overcoming the long delays of the radio link. So there are changes in the random access procedure, there are changes in the hybrid RQ procedures. We also need to support FTD. So FTD is actually part of this tool. Today in 5G NR, we only have support for TDD, but for non-terrestrial networks, we need FTD. That I think this non-terrestrial networks also require lower subcarrier spacing, so we'll be integrating also the 15 kilohertz subcarrier spacing right now. There's a paper, I can maybe copy the link in the chat afterwards, that summarizes all the different plans for these non-terrestrial networks.
Yeah, that would be great. Thanks.
And for the uplink MIMO, yeah, so that's not very detailed on purpose here because that still needs to be refined. Mm-hmm. That's again driven by BUPT in China. But the goal is to have increase the throughput on the uplink and support multi-layer transmission on the uplink.
All right. Okay. So thank you very much for this interesting talk. I think it really was a good follow-up on Shweta's tutorial. We have seen like how you can use OAI, and we've seen the roadmap similar to what we did yesterday for SRS run. Okay. So thanks again for being available. And there are still a few questions on the chat. Unfortunately, for time constraints, we'll have to move to the next session. But if you have a couple of minutes, maybe you can stick around and take a look at it.
If I understood correctly, my colleague Raymond will be joining for the panel discussion later, so I'm sure you can direct some questions to him too.
Yep, sure. All right.